Imagine waking up one morning and discovering that the very devices you have depended on for decades, your laptop, your smartphone, even your smartwatch, have suddenly become relics of a fading era. This is not science fiction, but the vision outlined by Sam Altman, one of the most influential figures in artificial intelligence today. Altman, the CEO of OpenAI, recently made headlines with a seismic statement. The computers we have built and trusted for so long were designed for a world without artificial intelligence. In his words, current computers were designed for a world without AI, and now we're in like a different world. Let that sink in. The very foundation of our digital lives, the hardware that powers our work, play, and communication, is now out of step with the needs of an AI-first world. But what does that really mean for you? How could the next generation of computing reshape not only the tech industry, but the fabric of society itself? To understand the upheaval, let's rewind a bit. For nearly half a century, the evolution of computers followed a reliable, almost comforting path. The early days were defined by clunky mainframes and punch cards, but soon, the personal computer brought the mouse, the keyboard, and the glowing screen into every home and office. These interfaces became our trusted toolkit, universal symbols of productivity and connectivity. Under the hood, central processing units, or CPUs, ran the show. These chips crunched numbers, powered word processors, calculated spreadsheets, and rendered video games. Then, in the last decade, the rise of deep learning changed everything. Suddenly, the old workhorses, the CPUs, couldn't keep up with the demands of neural networks, the computationally intensive engines behind modern artificial intelligence. Graphics processing units, or GPUs, entered the stage, unleashing a new era of parallel processing. GPUs made it possible to train massive AI models, analyze oceans of data, and fuel innovations like self-driving cars and real-time language translation. This hardware leap catalyzed the explosion of applications like ChatGPT, DALL-E, and countless others. But here's the twist. Even with these advances, our core hardware, the structure of our laptops, the architecture of our smartphones, remains fundamentally anchored in the past. The world has changed, but our machines are still speaking the language of yesterday. Today's artificial intelligence is not just about speed or raw computational power. It is about context, about awareness, about the ability to perceive and interact with the world as humans do. Consider this. A recent industry report projects that the market for artificial intelligence chips alone will soar to nearly 400 billion United States dollars by the year 2027. To put that in perspective, that is more than the entire annual GDP of many countries. It is not just a sign of rapid growth, it is a signal of a revolution. Computing is being redefined from the ground up. Enter the innovators. Around the world, engineers and researchers are racing to build machines that are not merely faster or smaller, but fundamentally smarter. One of the most exciting frontiers is neuromorphic computing. Inspired by the structure and function of the human brain, neuromorphic chips promise to deliver a quantum leap in efficiency. Imagine a chip that can process information while consuming less than 1 milliwatt of power, orders of magnitude less than today's most advanced AI processors. For comparison, the brain of a tiny cockatiel parrot, weighing just 2 grams and running on about 50 milliwatts, can perform feats of perception and adaptation that today's silicon cannot match. Neuromorphic architectures bring tantalizing possibilities. Imagine event-based cameras that do not simply record every frame, but transmit only the changes in a scene, sending updates in mere microseconds. This approach slashes data requirements and enables real-time responsiveness. Or picture AI-powered home robots that can run on a single battery charge for days, learning and adapting as they go, without constantly sending data to the cloud. This is not just about making devices faster. It is about making them truly intelligent, responsive, and deeply integrated with our daily lives. But what does real intelligence mean in this context? According to leading experts, real intelligence isn't just about prediction, it's about perception, interaction, and action, and that all starts at the hardware level. In other words, the next leap in artificial intelligence will not come from software alone. It will require a total reimagining of the very foundation of our devices. Some researchers even argue that a 2-gram cockatiel brain's efficiency and adaptability far outstrip what our most advanced chips can do today. Imagine a world where your device seamlessly knows what you need, when you need it. It could detect your mood from the tone of your voice, anticipate your questions before you ask them, and adjust your environment, lighting, temperature, music, to match your preferences, all without a single tap or swipe. This would be a profound shift, not just in technology, but in the way we relate to machines. And lurking beneath the surface is an even deeper question. Will this new era of hardware bring about a future of empowerment, openness, and joy? Or will it tighten the grip of a handful of tech giants on our digital lives? As one expert warns, we are witnessing a crisis of disempowerment. This is about fighting for the kind of future we want. If a few corporations control the hardware and infrastructure that mediate our reality, the risks go far beyond data privacy. They touch on the very nature of human autonomy. Let's look at what might be coming and how soon. Altman and his team at OpenAI, in partnership with Jony Ive, are racing to bring their vision of the third core device to market, possibly as soon as late 2026. But what will daily life actually look like in this AI-first hardware era? Who stands to win and who might lose as our most personal devices become more autonomous, context-aware, and perhaps even creative? Imagine waking up in a home where every device around you is not just smart, but truly intuitive. Your smart speaker does not just play the news, it senses your mood, adjusts the playlist, and reminds you of a forgotten appointment. Your refrigerator suggests recipes based on your dietary goals, and the lighting in your living room subtly shifts to help you focus or relax. All of this happens seamlessly, without you having to stare at a screen or type a single word. This is the promise of the AI-first hardware era, a world where machines adapt to you rather than the other way around. A leading researcher put it bluntly, this is about fighting for the kind of future we want, a future of openness and joy, not just efficiency. The stakes could not be higher. Will the AI-first era empower billions of people, giving them more control, privacy, and freedom? Or will it create a new generation of digital monopolies, where a few players set the rules for everyone else? Let's talk numbers, because the scale of this transformation is astonishing. As noted earlier, the artificial intelligence chip market is projected to reach nearly $400 billion United States dollars by the year 2027. By the year 2030, edge artificial intelligence hardware, the chips and systems that bring intelligence to the very edge of the network, close to users, could exceed $58 billion United States dollars. Just between the years 2025 and 2026, experts predict a remarkable 41% surge in artificial intelligence device adoption. These are not incremental changes. They are signs of a seismic shift underway in how technology is built, delivered, and experienced. But with great power comes great responsibility and great risk. As new hardware architectures make devices more personalized and responsive, they also raise the stakes for security, ethics, and even the nature of work itself. If AI hardware becomes more context-aware, how do we ensure that it respects boundaries, avoids biases, and preserves human autonomy? What happens to jobs that may disappear or be transformed beyond recognition as machines become not only smarter, but also more resourceful and omnipresent? Let's take a moment to imagine some of these scenarios. In healthcare, AI-optimized hardware could enable doctors and nurses to diagnose illnesses in real time, using portable devices that analyze vital signs, scan images, and even predict patient outcomes, all while safeguarding sensitive patient data. In transportation, edge artificial intelligence could allow autonomous vehicles to make split-second decisions, improving safety and reducing congestion. In manufacturing, neuromorphic chips could bring a new level of flexibility to robots, allowing them to learn new tasks on the fly, adapt to changing environments, and work alongside humans more safely. But there are challenges as well. As the line between the digital and physical worlds blurs, questions about surveillance, consent, and control become more urgent. If your devices are always listening, always watching, always predicting, who decides what is appropriate? How do we ensure transparency in how decisions are made? Can we build systems that are not only powerful, but also fair and accountable? So what does all of this mean for you, the viewer? First and foremost, recognize that we are standing on the threshold of a new era. The devices you choose to buy in the next few years may shape not just your productivity, but your privacy, your health, and your sense of agency. As neuromorphic chips and edge artificial intelligence enter the mainstream, it is crucial to ask tough questions about transparency, data usage, and open standards. Demand to know which companies are building with your interests in mind and which are chasing monopolies or short-term profits. Second, Stay curious and adaptive. Learn about the principles of artificial intelligence hardware. What makes a chip neuromorphic? Why does edge computing matter for privacy and speed? How might screen-free AI devices soon integrate into your daily routines? The more you understand, the more you can shape your own digital destiny, rather than simply being swept along by the tide of technological change. Third, engage in the broader conversation. As designers, engineers, and policymakers make decisions that will shape the future of computing, your voice matters. Participate in public debates, support open-source initiatives, and push for ethical standards in the development and deployment of AI hardware. The future is not just being built in Silicon Valley or Shenzhen, it is being shaped by the choices of billions of users around the world. And here is a fascinating detail that few people realize. The race to design the next generation of third-core devices is taking inspiration from the remarkable efficiency of nature. The humble cockatiel parrot, with its 2-gram brain running on 50 milliwatts of power, can perceive, interpret, and interact with its environment in ways our most advanced chips still struggle to match. Engineers are now striving to build machines that echo this biological brilliance, devices that are not only smart, but astonishingly efficient, adaptive, and, perhaps one day, creative in ways we have only begun to imagine. Let's pause for a historical parallel. Just as the arrival of the automobile transformed cities, economies, and daily routines, the dawn of AI-optimized hardware may reshape everything from how we learn and work to how we connect with one another. In the early 20th century, skeptics doubted that people would ever abandon the horse and carriage. Yet, within a generation, the world was remade. Today, we may be standing at a similar crossroads, wondering whether we can truly move beyond screens and keyboards, even as the next wave of innovation gathers momentum. What are some possible futures? In an optimistic scenario, new hardware could democratize access to intelligence, making advanced tools available to billions of people, not just the privileged few. Imagine affordable AI tutors in every classroom, empowering students from rural villages to urban centers. Picture home healthcare devices that monitor chronic conditions, catching problems early and reducing medical costs. Envision creative tools that help artists, writers, and musicians express themselves in new ways, powered by hardware that understands their intent and adapts in real time. Yet, there are darker paths as well. If the design and control of these systems remains concentrated in the hands of a few, the risk of digital monopolies grows. Imagine a world where your only choice is to buy hardware from a single mega-corporation, where every interaction is mediated, monitored, and monetized. In such a world, autonomy and privacy could become luxuries rather than rights. If you found this exploration eye-opening, make sure you subscribe for more deep dives into the future of technology and global economics. What do you think? Will AI-first devices make your life better, or are you worried about who will control them? Let us know in the comments below. Your voice and your choices matter in this new era.